know what the group 0 elements are, let's think about some of their trends. We saw on the last slide that all of the group 0 elements are gases at room temperature. This means that they all have low melting and boiling points. Because by the time you get to room temperature, they have already gone from a solid to a liquid, they have melted, and then they have boiled from a liquid to a gas. However, we can still identify a trend or pattern in the melting and boiling points of the group 0 elements, which is that they increase as you go down the group. This means that helium has the lowest melting and boiling point, where I've just used a shorthand, MP for melting point and BP for boiling point. Melting and boiling points will increase as you travel to neon, argon, krypton, xenon and radon will have the highest melting and boiling point. Let's think about why this might be. As we travel down a group in the periodic table, we know that the atomic number and therefore the number of protons increases. For an atom, the number of protons will be exactly the same as the number of electrons. So as we travel down group 0, the number of electrons also increases. Intermolecular forces are what hold the atoms or molecules in a solid together. And we generally see that the more electrons involved, the stronger the intermolecular forces. These forces are what need to be overcome in order to transition from a solid to a liquid and from a liquid to a gas. The stronger the forces, the more energy is required to overcome these forces and allow the transition. Therefore, at the bottom of the group, there are more electrons, there are stronger intermolecular forces, and therefore more energy is required to overcome these forces. This means that higher temperature is required, and the result is that the melting and boiling points increase with the number of electrons. The energy required is given in the form of more heat at a higher temperature. Remembering the trend that the melting and boiling points increase as you go down the group allows you to predict properties of the noble gases. For example, if we think about boiling point, we know that the boiling point of krypton is minus 153 degrees Celsius. Given this piece of information, we can then start to think about what the boiling points of xenon and radon might be, remembering their positions in the periodic table, which is that krypton is followed by xenon is followed by radon moving down the group. We therefore expect that the boiling points will increase moving from krypton to xenon to radon, and this is exactly what we see. The boiling point of xenon is minus 108 degrees, and the boiling point of radon is higher at minus 62 degrees.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.